Hey, 1 minute while I set up here. Okay, the stream for today is about returning to the design workshop. This idea, I think it's good. I don't have software to write for this game down below called Small Towers, or the other game that we're making called Shuffle Wars. I don't have code for that to write, because at this time, they're kind of done. Truth be told, I did actually do something to Small Towers this morning. Tweaking ever so slightly the AI, the bots that play as players, one of two players. Their AI is just a garbage mess that I have been embarrassed to show on stream, and I would frankly refactor it. Maybe that is a software development stream to do someday, but not today. What I really like is this new idea. And by the way, if you show up on stream, please use Command Tie, like I just did. Command Tie lets me know you're here. Thank you. If you're wondering what the heck is going on, this cartoon ape, the blinky lights, the tricks, what the heck? This cartoon ape in a jungle makes games. And we do play games. There's gameplay involved in everything we're doing. We talk about design of games, and we have to make games to demonstrate proper design. So there's some making of game, art and code, story, and there's talky talk time. This is not that time. There's another stream that I have now changed to fit closer to this one. This software and development style of stream works if you're like in the game engine and writing code. And since I don't have code to write, like for this game, Small Towers, then what are we doing? Well, I figured we can do what's called a design workshop. Design workshop could be a place where we make a thing, make a small thing in the workshop, something that you can do. I like the idea that it's like an hour of doing things. Making a small thing, a very common thing you would do in a game, this is a format I think we can do. Last time, we said you can do pixel art. We said you can do pixel art. Oh, I need to actually... I said I was ready to go, but I just totally wasn't. I need to check the sound before I go any further. And, of course, I have to deal with the Twitch app and all that garbage. And, you know, hey bots, what's going on? The bots will play this game. If you want to play, you can. You'd rather play the game than watch me do my thing, that's totally fine. Sound check is good. Let's roll. So we're here in what I'm going to call the design workshop. Last time in the design workshop, which, you know, this is much less intimidating than like code, right? That's the point. I don't want to be here. What's this ape doing? This ape is telling you, you can do this too. I'm convinced you're here on Twitch, you know games, you play games. I'm convinced of that because you're here on Twitch. I'm also convinced if you're here on Twitch, you might be looking on your phone. But it's also just as likely you're looking at this on a machine that could totally make games. You have enough hardware. The software you'd need is free. We talked about this one, GIMP, last time. Last time we said you can download this for free, and you can do exactly what I'm doing now. Last time, we made pixel art. Last time, we said, let's draw a square image in GIMP and bring it into the game engine, and the image we decided to draw was a coin. We filled it in, colored it in, made some highlights and whatever, some details, and we brought this image, the square image, we brought it into the game engine on a square. And so we use two programs, GIMP and Unity, where Unity has a camera pointed at our square. I am trying to draw the camera and my tablet is inadequate. Santa, all I want for Christmas is a new tablet. The camera in the game engine points at this square. I mean, that's all we did last time. Nothing fancy. And it demonstrated two things. First of all, the applications, GIMP and Unity, and how they're free. You can use them. This is not hard. And then we demonstrated you can draw in GIMP, make the image, import it into Unity, and you have game art. We even talked about some of the details about that. Okay? I encourage you to look at Design Workshop number 1. This is Design Workshop number 2. What are we going to do? Well, it's cool that we have this piece of art in the game engine. This was a very common thing that people would want to do in their games. So, yeah, this was a great place to start. This needed to happen for Shuffle Wars. This needs to happen for Small Towers. We make art and we bring it into the game engine. Now the game engine can use it. Okay? This camera almost looks like a character. This is an old style camera, like film would be wound up. Physical film would wind through here, frame at a time, and wind back over here. And this is just an icon to people today, but this was actually the shape of a thing, tool. Anyway, what are we talking about today? Let's make this thing move. This is a common thing too. If you're looking at the game down below, you're seeing a 2D game made up of game art, and they're all on squares, just like what we did last time. It's pixel art that I made in GIMP and brought into Unity, just like what we did last time. It took an hour. This will take an hour too. But the difference between what we did last time and what you see down below, well, there's a few, but one of those things is that it moves. We see the characters, for example, walk. And there's a couple of things going on there. One is the frames of artwork, because there's multiple frames, play in time and look like animation. So I can get the characters to idle. They sit there and it looks like they're bouncing up and down. They walk and it looks like their feet are walking. They swing their sword, they look like they're dying, they look like they took a hit, blah, 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 blah. But that's one type of animation. It's changing the images from one image to another image that's different, to another image that's different, right? This series of images, or array of images, could be numbered, and then we just say play whatever numbered image we have for that animation. For example, the sword swinging has like about 8 frames on it. He's got to lift his sword up and swing it, and then bring it down to a rest. And it takes about 8 frames to do it. Well, there's a list of 8 frames for his attack. When that character needs to attack, I have code that says, go find these images, pick from them, and go through them in that order, for sure, that order, and spend a little bit of time in between them. A little bit of time. Fraction of a second. It's a stopwatch. It's another tool nobody uses. Here's the thing. I'm going to refer to these old things. So, a little bit of time in between the frames. So as long as I've drawn the frames and they're in the engine, just like what we did last time for this one coin, if I have multiple frames, I can do one kind of animation, right? You could call this sprite animation, and I wouldn't fault you for it because that's what it looks like. It is pixel art, and we are changing the frames. So yeah, I mean, sure. Technically speaking, however, a sprite is just organized differently, but the concept is exactly the same. I say it's organized differently because instead of separate images, just like what we did last time, we would combine the images in what's called a sprite sheet. If you Google sprite sheet, you'll find lots of examples of pixel art characters where this is organized. It's still a series of images for one thing, and then it's another series of images for another thing, and then it's another series of images for another thing, and they're all kind of packed together in one image. This is called a sprite sheet. Okay. I don't even use that for small towers. I don't do it this way for small towers. Why? It's just, this is simple. This is just a series of images in the game engine. Game engine can totally handle it. And it's simple and easy to organize, and why not, right? This is organization that was necessary when computers were old. I mean, when long ago, when computers were weak and could barely hold anything, packing your pixels into a single image was a lot for a computer to load in and deal with. Switching images would have been a bigger deal. And so they packed all of the sprite frames in one image. Okay, so this is old technology that we don't need to do anymore. We don't need to do that. I assert we won't do that. I could certainly show you this. Unity still has a sprite sheet tool, and you could totally do that. It's nostalgic, but why? Who cares? This is just simple. This is, if I want to do sprite animation, I'll just make different images and we'll switch them out in time. Done. Right? It's a small amount of time. I think for these frames you see on the characters, on the average, it's about 0.15 seconds. So a frame will hold for that long, and then the next frame for that long, and the next frame for that long, on average. Different animation sets hold for different times. We can talk more about animation another time because, frankly, animation is a large subject. I know something about that. And everything from like a bouncing ball, right? Ball's up here and it's going to fall, and it starts out slow, right? And it goes faster, and then it goes really fast. And look what I mean when I say fast. It is moving more. Same amount of time per frames, but it is moving more. That's speed, right? And then it squishes on the ground, right? Lots of concepts we can talk about. And then it bounces up and roughly looks about the same on the way up. This bouncing ball could be frame 0. I will count from 0, and you'll ask me why later. Frame 1, frame 2, frame 3, frame 4 when it's squishy. And then I'll just go backwards. I'll say 3, 2, 1, 0, and 1, 2, 3, 4. And this will look like a bouncing ball. We could talk about animation some other time because it's a deep subject. This is one kind of animation. If you define animation as simply, pictures that appear to move, right? All video and moving images are just a series of images with slight changes between them and a little bit of time, small amount of time, between each frame just holding on the frame. We can talk about that. That's one type of animation. I'll just indicate this is old technology. We don't need to do this anymore. We certainly could, but it's literally for nostalgia purposes. Instead, let's talk about a different kind of animation. The other kind of animation being demonstrated down below. It's literally this. This arrow indicating that the coin could just move. Okay? Not only does the characters you see down below animate like they are walking, they also move. This square where the coin is on can move. So the camera is going to sit there and just not to confuse things, but the camera could also move. And the camera's going to sit there, and what we're going to do is let it look at the coin moving across the screen. This is a baby step. This is one step we can totally do. In the process, I've already started to talk about the fact that there are two types of animation you see in the game, but down below. Those are common. Doing animation on your artwork is common, right? And while we did sprite art last time, what I'm going to reserve for another time is that kind of sprite animation. And today, what we're going to do is just moving a game object. So we'll go into the engine, we'll look at our coin, and we'll just make it move. This won't take long. This is a baby step. How do I say this again? This is a step you can do. No offense to babies. No shame. We're going to make this move. And because it looks 2D, and it is roughly a 2D kind of environment, we might set up Unity to look like it's 2D. Here's what I mean. We're going to let our coin sit on a square, and the only ways it can move are going to be up and down and left and right. I hate my tablet. So this square with the coin on it, this image of a coin on a square, I hate my tablet. I'm looking somewhere and I'm drawing somewhere else. It's like the worst setup. But yeah, we're going to let it move up and down, left and right, and that's it. The camera will stay where it is, and we're just going to concentrate on this. Could we make it move forward and back? Well, we could, but we're not going to, because we're going to let the pixels on this artwork look like pixels. We're faking that it's necessary. We need to draw it in pixels. We simply don't. But we're going with the style of pixel art. We're going with the style of an old school 2D game, similar to what we did with Small Towers down below. So we're just going to move up, down, left, right. In making that object, this card, this square with the artwork on it, and making this move, we are going to recognize that it is in 3D space, however. I mean, there is a camera over here. And if this was literally 2D, there would be no over here, but there is. This is a 3D engine, and we are just ignoring the depth and allowing things to look 2D. That's fine. But this camera is over here, right? It is in front of the coin, right? The coin is like here at 0 and back here at -1, -2, -3, -4, -5, 10, something. There's where the camera is. And that's is in this direction, forward and back. If it was forward, it would be, gosh, I hate this. This is going to drive me insane. Way over here is in positive Z. And back here is in negative Z. What do I mean? This is an axis. Forward and back really is forward and back along the Z axis. Why Z? Why are you calling it the Z axis? Well, math. Math has a convention of calling things like this, and you may have been familiar with charts that, graphs that have, lines like this, and it says that this is the x-axis and this is the y-axis. You might be familiar with that, so you can draw little dots, lines and things like that, right? Well, where's Z here? Well, it would be depth. If our camera is looking here at our card, we don't see the depth, especially if we modify this camera so it can't see depth or perspective. We will do that. So we'll modify the camera so it doesn't see any depth. We will ignore the Z-axis altogether, and instead we're going to concentrate on the X-axis to move left and right. We're going to concentrate on the Y-axis to move up and down. That said, please remember, we are actually in a 3D engine, and so to make this move, we're going to have to at least give a nod to the Z-axis, treat it with some respect. What we talked about? What do you mean? When I move it at all, it still has a position in X and in Y and in Z. If I move this card with the coin object on it, I swear this tablet is going to drive me insane. I need to stop and look over at the tablet to figure out where I can put my stylus, and then I can go back and look at the drawing. Okay, I can't describe how frustrating this is, but I can just vent. So there is this card with a pixel art coin on it that we made. It's sitting in the game engine right now, which means it is in a position in X and Y and Z right now. If I remember correctly, the Z position is 0. In fact, I wouldn't be surprised if, X and Y were close to 0, right? I'll bet the X is 0, and I bet the Y might actually be something like 2. Why? Why is Y at 2? Because I think there's some visible, procedural generated horizon that makes it hard to see, and so I just moved it up a little bit, way off in the distance. It's not real, but it is meant to look like the background. I'll show you. What I mean, though, is that right now it has a position with 3 numbers, and we're going to have to deal with 3 numbers all the time, even though we don't care about the Z-axis at all, even though this is supposed to look like a 2D game. Unity began as a 3D engine, and it still is a 3D engine, even if you want to make it look 2D. There's nothing wrong with that. In fact, it's helpful to have Z, for example, to use as layers. Just like the layers here in GIMP allow me to draw a goofy face and then fill it in with a background layer of, I don't know, blue-ish, something. I can do this because of layers. The background now be painted on, and the line drawing is on top. This allows me to keep one and play with the other. And the depth in our 3D engine allows us to do exactly the same thing. Okay, this is garbage. But you get the idea. Let's go ahead and use all three numbers in our game engine to move this coin. We have to respect the z-axis and actually name it. So if we recognize right now it is at some position like this, 0, 2, 0, meaning x, y, and z is 0, 2, 0, then if we wanted to move it, say, to the right, it might be a positive number in x now, like 2, while the y stays the same and the z stays the same. So it might end up over here. I'm not saying anything that doesn't make sense to people paying attention. Okay, if you're bored, hold on. Because to do this in the engine is one thing. To say just change from over here to there, and it just moves. But to do it in the game, like what you see down below, means that we are going to do it over time. A little bit of this movement over time. And if that sounds similar to the sprite animation we were just talking about, that's because it's also animation. This is movement animation or translation. And what I would really like to do is, first of all, say that there's more than one way to do things. In code, in the game engine, there's always going to be more than one way to do things. We are going to show this movement animation one way today, and we'll come back and do it a different way another time. Why? To show you that there are different ways, but also today I get to focus on these three numbers. This x and y and z, and paying attention to them is part of what allows us to do anything positioning a game object in the game engine at all, and doing it over time. We can do that now and learn about these three numbers. Three numbers. In fact, these three numbers, like you see how this is an arrow, right? This is an arrow, and it's implying that it started here at this position, but that it has moved over here to this position. This is a single direction of an arrow that implies two positions. It actually implies a difference between this position and that position, where this number, this first x value, went from 0 to 2. Everything else stayed the same. That's what this arrow represents. Isn't that interesting? It's just a number, or it's three numbers, but it implies that it was a direction. It implies that it was a movement. This is, in math terms, called a vector. So here's some learning. A vector is something that looks like this arrow, because it does imply there was a starting point, but that there is change. The vector implies this distance change. If I'm looking back at this small graph with an x and a y, let's do it in 2 dimensions for a second. I'm here at 0, 0, right? The x and y value, 0, 0. And I can also put a dot over here. Let's do the math. This is 1, 2, 3. This is 1, 2, 3. Then the x would be 3, and the y value is 1. Okay, a couple of dots on this graph, big deal. What are we talking about? Well, it's implying this is an arrow. It's implying the same change that we're talking about over here. It's implying a vector. Especially since this is 0, 0, it's very easy to see that this is a vector defined as 3, 1. Positive 3, positive 1. It's implying this arrow change in position from somewhere over 3 and up 1. In fact, if I were over here and I applied that same vector, it would go over 1, 2, 3 and up 1. It would be right here. It would look exactly the same arrow, same length, same angle. That vector is a change in position. That's what a vector is. This is a 2D vector. Is my avatar in the way? It's a 2D vector. But I just used a new term, and it's okay. You learned what it means. It is a change in position. That's what a vector is. And a 2D vector just has two numbers to worry about. The change could come from 0, 0, but it could also come from somewhere else. The same vector 3, 1 is applied here, and they both kind of look at this like the same angle and same distance. They end up in different places though, and how do you know where that is? Well, I can just do addition. If I started here at 1, 2, is that what this is? Then I do the math. I add 3 to 1, and I add 1 to 2. I'm going to get, what, 4, 3? Yeah, that's what this is. So that's the result position after that change. The vector tells me that if I go from 1, 2, I'm going to end up at 4, 3. This vector is still described as 3, 1 because that's the amount of change. Whether it's here or here, that's what a vector is. It's change. It's position change. So you learned a new word. That wasn't so hard, right? In our case, we actually need to work with a 3D vector because it's in the engine and because we don't want to disrespect the z-axis. In code, in the engine, this is literally called a vector 3. Yes, there is a vector 2, there's even a vector 4, but we only need to worry about a vector 3 to describe all three of these numbers. Why do we call it this? Who cares? Well, the game engine cares, and the code would care, because implied in this one thing called a vector 3 are these three numbers. And if we want to change the position of a game object, it asks for a vector 3, meaning those three numbers, all packaged up as one thing. And so we can say, cool, it starts at this vector 3 and ends up at this vector 3. Change. Move the position. Done. So with this little description of what is up, like what we're about to do is make this coin move. Similar to what you see down below, it's extremely common to make your game engine object move. How do we do it? Well, first things first, learn that you are in 3D space, and something like a vector is necessary to make it change position. Now, don't forget, we also want to deal with time. But let's just move this thing first. Hey bots, what's going on? Small Towers is a game for chat. You can always play. If you do show up on stream, please use Command Ty. Ty lets me know you're here. Alright, back to it. Last time we were in the game engine, it looked like this, and I'm going to remove my avatar. Because we looked at this panel here and said this is a mirror of all the folders that are actually on your in your file system. There's a project of this name on your disk, and inside that project folder there's a folder called Assets, and I made a folder called Art, and we already had a folder called Scenes and so on. But we added an image. This is the pixel art image we made last time in Design Workshop 1. We made a material to put that image on, and we put that material on a square, otherwise a quad object, and put it in front of the camera. And we learned a little bit about this environment, which is to say we could see that it is 3D. We can orbit around this space, etc. This is a 3D engine, and yeah, I was right. We did move it up a little bit so that you could see it from the camera's point of view. This looks flat, good. And I moved it up so that you could see it was against the sky. Sure enough, I did move it up some. So here's X, Y, and Z. So I moved it closer to the camera as well. I moved it up to -8. I'll keep it there for now. But this is what I mean. Here's X. I'm going to just click and drag this, and I can see that it changes. And this is the same thing as grabbing this arrow. We looked at this last time. You can move game objects by grabbing the arrow and doing this. Well, I can also just type in numbers and do that. Right? So we had something like this last time, roughly. This is the position of it based on this one component. We learned briefly about components and the fact that they all do one job, like render the image or define the quad shape, for example. This component is available on every single game object, even an empty game object. Transform is always there. It's always there, as is the name of the game object and whether the game object is on or off. All game objects have a transform component so that it can be in a place. That's what the position needs to define for every game object. It can also be rotated. Check it out. So, yes, I can also scale it. And notice that everything is 0 except these scale numbers. This is 1 by default. What's that about? Well, it's literally 100%. So if I wanted it to be 50% of the width, it's now very thin. Or I could set it back to 1, and it's 100% the width that we drew originally. Same with the scale in Y. And how come we don't see any difference when I scale this up and down in Z? Well, it is a flat plane, basically. There's no thickness to it because it's of the shape. It's a quad. It's just a square. So this is the kind of change that we're talking about. To make it move to the right, we're going to change this number. Let's just say we're going to go from 0 to 1. Okay? This is exactly the same as what you see the characters doing down below in Small Towers. I needed to have the characters animate in sprite animation, sure, but I also needed the game objects of each character to move. Left to right. So it's exactly the same. To make it move here in the scene and then save it is one thing. Like, I've just set the coin to be in that position and save the scene. That's one thing. It'll remain there, though. And what I want to do is, like, hit play and watch it change. Well, we don't have any rules of the game implemented in such a way that it would move. In essence, the only rule is render a coin in front of the camera at this position, and it's doing it. It will keep doing it forever. There's nothing to do. So play does nothing right now. But what we can see is what we want it to do is this. Go from 0 to 1 over time. This change is the X value on a 3D vector. We just learned all these terms, and wow, don't you feel smart? Let's do it. I'm going to, now that I've played with it in the engine enough, and this is always the first step I do, is try to figure out what I want to do based on what I'm playing on in the engine. I'm coming to this X value right here, I'm doing that. I'm going to leave these other numbers the same. I know I'm dealing with a vector 3. I know I'm dealing with all 3 numbers, but I'm leaving these other ones alone. Just playing with this. I'm looking at the fact that this is the coin, its transform component, and the position is where I find the number that I want to change. Now, I'd like to just change it, and eventually I want to change it over time. So let's do 2 steps. Step 1, let's just change it. When I hit play, I want it to move from here to here instantly. Just boop, like that. And then I hit stop, and it goes back. That's what I want. I needed to manually move it just then. But let's see if we can get the game to do it for us. I have a rule. The rule is this. I'm going to hit play, and I want the coin to move over. Implementing a game rule is why we have code at all. Instead of me manually changing the position of the coin, instead of me figuring out if you got 3 in a row in tic-tac-toe, instead of me flipping a coin for you as we play those games, I want the game engine to do it. And that's why I need code, because I can define the rule. Can't the computer just follow the rule for me and make the game happen? Yeah, that's why it's there. So I'm going to write code. No, you're going to write code. Relax. Let me show you. We imported this image. We said right-click, import new asset, and we brought in our image of this coin. We also made a material last time. Do you know how we did that? We right-clicked and we said create material. Okay. Now, we configured the image and the material. We configured these things. But to make it was easy. In fact, we spent more time making folders. Let's make folders. Like literally, baby steps, right? Excuse me. No shame to babies. Small steps we can all do, right? That's what we're talking about. I'm going to right click here, make a folder, create folder, and I'm going to call it scripts. You can do this, and you can do this too. With that folder selected, you can go back, right click, say create, and just select this. It says C# script. And if you're saying, oh, I can't, well, get over it. I think we talked about this in our design chat last time. And what happens? Well, we have this new thing under the folder. It says something like new behavior script. Okay.
Ladies and gentlemen, welcome.
I appreciate you being here. And thank you for following. LA Gamer Dad. Awesome. Thank you. I appreciate you being here. You're welcome to lurk. Do you know what we're doing? We're in a game engine and we're making this little sprite image move over. And we got about 20 minutes left. We'll make it happen. Thank you for following. I really appreciate you. And thank you for using Command Tie. When you show up next time, use Command Tie. Here, I'll give you all the secrets. Just to prove that I think you're special. Give you all the secrets. Next time you show up, please use Command Tie. You're welcome to lurk. I'm going to move on because we got to write some code. Oh no! So we right-clicked. We said, "Give me a C# script," and it put us here. And it's sitting there highlighting the name of something. It's a file. Relax. It's really just a text file. But the name of the file matters. In this case, it is a set of rules. And I just want the coin to move. Can we just call it like move coin? Sure. I'm down. I'm going to make it all one word, though, if you don't mind. I'm going to capitalize the name, move, and then I'm going to leave no space. I'm just going to write another word with a capital coin, and then I'll hit return. Now, it's interesting that it gave us this time to name the file right now. I'll explain why another time. Just follow me here. If you went ahead and hit enter on accident, it's no big deal. It's just that, check it out. It's showing us the preview of this code. And you can even read the word move coin right here in the preview. If you hit enter, it's just that this probably says new behavior script. No big deal. You can make this match this. As long as these match, that you're going to be fine. So you can go back and fix that if you want. But that's why it had us sit there and think about the name of this. I'm going to call it move coin. Is that okay? Yes. Actually, we're going to find all of this is okay. This is just text. And if I double click on this, and I have installed Unity to do so, by default it is set up to launch something like a glorified text editor. What's up, Eggs? Hey, thanks for lurking. I really appreciate you. If you feel like lurking, please do. I welcome the lurks. And I think I'm already lurking everyone in the universe, so hey! Yes! Welcome to lurk. So, I'm going to go back to this, because literally we brought in some pixel art last time. This time we're going to make this coin move over to the right. So move coin is a script that we are going to write today. And like I said, if I double click on it, I'm going to open a new program. It's made to work with Unity as a code editor. It's just text though. Its fancy name is an integrated development environment, or IDE. But relax, chillins. It's okay. It's just text. Look, you can read it right here. It's just text. Relax. Now, can I edit it here? No. But okay, it's okay. I could open it here, or I could double click here. It's the same thing. In case your experience differs at this next step I'm about to do, in case it's different, you can go to Edit and find Preferences. And the first thing that's going to be highlighted is something called External Tools, and up at the top of that is going to be what glorified text editor am I going to launch when I double click on scripts. That is what this is. And so you can click on this and find the one you should have if you have any problems. But if you install by default just normal, if you install Unity by default, this is already set up. This is just if things got goofy, you can fix it there, okay? Otherwise, you can just double click here, or you could hit open, I guess. I will double click. And it takes a second. But what is this? Oh my gosh, this looks, relax. I'm going to maximize this window and just tell you to relax. Do you see anything other than text on the screen? Well, there's some buttons and stuff, but relax. There's nothing here. It's just text. I'll make it bigger or smaller. I'm going to hold down Control and wheel mouse up and down, right? I could also use this thing to resize it, but just relax. It's just text. In fact, look at this. I'm going to put my cursor right here. There's these curly bracket things we will talk about some other time, but just chill. My cursor right on the end of it and hit enter. No, you're changing code. Is it going to break? No, relax. I assert you should relax. I'm going to type a slash, exactly like the slashes we see down here. I'm going to type two of them. 1, 2. No! Are you breaking code? No, I'm not. In fact, everything I type after this is totally cool. I can just go nuts. Really? Yeah, look. I'll hit save. This is the save icon. It's nothing fancy. I'll minimize this again, and we'll let Unity read what I just wrote, and look, there it is. Isn't that silly? Yeah, it's safe to write anything after those little slashes. Let's do that again. Relax. I'm going to simply say, you know who wrote this, this fancy C# script? Yes, I did. That's how fancy I am. In fact, I'm going to say that this script moves the coin. Bro, really? You just put in extra lines and everything. What is this? Well, relax. It's text. No joke, man. No joke. Oh, right on. Yeah, Unreal. I don't have anything against working in either Unreal or Unity, Eggs, but I find uh, learning is much easier on Unity, and the concepts are exactly the same. And whether you're using Blueprint or C#, you're still going to learn the same stuff in code, same stuff in the engine, 3D vectors and position and all that stuff. It's very interesting. I didn't know you were learning game development. That's super cool. Now we're going to have something to talk about. Look out. So I'm going to come back to this and finish this up really quickly. We wanted to move the coin, and I mentioned that there's something called a vector 3 that defines where this coin is right now. It's at 1.58, something like that. Right? But we want to move this coin. I want to hit play and move this coin from here to here. Right? So I'm going to worry about a vector 3 that is on this coin. Where's my script? Well, it's in my project, but it's not on this coin yet. It can be. Any game object can have your scripts on it. In fact, you can have any number of these objects. I could just copy and paste and make a bunch of coins. I can. I'm rich. I'm totally rich. But it's what we're worried about now is the rules of this rule that we made, that as soon as I hit play, I'd like the coin to move over. Well, this could handle rules, but it's not on the coin yet. I can just click and drag it and drop it. And now my script is on the coin. It doesn't have to have scripts on it. There's these that don't have special scripts on them at all. But we want this coin to follow a rule, so that's why I'm going to put our script on the coin. That's all. I literally just dragged and dropped it here, but I could also drag and drop it there. And now I have 2, which I don't need. I'm going to remove it. So wait, this is our script? Yes. A copy of our script is on a object that has our image on it. Yeah. And what that means is that this is like right here and has direct access to this game object, including the name and whether it's active and its position. It has access to the other components as well. One of the things I like about Unity is just how easy it is to just mix and match these components. We can make a component too to run our own rules, and boom. Well, let's do that, because the rule we said was when I hit play, I want this coin to move. How come it's not moving? Well, because our script is here, but it doesn't actually do anything yet. Let's make it do something. I said, this script is going to deal with the position of this coin. The position is a vector 3 number, or a set of numbers, x, y, and z. So I need my script to remember those numbers and manipulate them. In order to manipulate them, I need to remember them. I need to store them. To remember and store something for use in the rules. I mean, the rule is move the coin, but implied in that rule is that we know where it is and where it will go, right? In other words, it's implied that we need to remember its position. If I just start typing vector, this glorified text editor begins to say, oh, you mean like a vector 2 or a vector 3? Like, it kind of knows. Like, what is all this? Was this crazy? Like, what? Well, no, this is trying to help you write code. That's what it's trying to do. In fact, it's explaining more things than we know about right now, which is why it looks weird. But relax, chillins. Look, here it says vector 3, just like we just said. And well, it turned green. What does that mean? Relax, chillins. It is trying to help us write code. Because it's text, it's helpful to have some things highlighted different colors, and so it is. That's all. We need this script to handle the rule that remembers where this coin object is, and that coin object is X, Y, and Z, and it's collected together in something called a vector 3. So I'm going to store this position as a vector 3. I'm going to store that change. Remember, we said vector was change in position, right? So I'm going to say it's a move. Sure, I'm going to call it a move. I'll call it a move direction. How about that? Because we did say vectors are change, right? And notice I'm sort of like deciding what name to give this storage, this box full of numbers, this little container that will remember where this object is and where it needs to move. Well, the move direction I'm going to say is going to be called move direction. It is a vector 3. Right? I'm going to add one other word to this line of code that we are actually writing right here. And I'm going to go to the front of this line. Right? Notice it's sort of indented here. That's important too, but we'll talk about why later. I mean, the computer doesn't care at all, but but it's easier to read. It's helpful that the program is just automatically doing this. I'm going to put one more word here. Relax, relax, relax. I put a little space between these words. They highlight in different ways, but whatever. I put the word public in front of this. Why? What is that? Why does that match what says up here? Like, what is all this? Relax. Did I tell you to relax? I told you. At the end of this line of code, I see a little red squiggly thing. And if I hover over it, it's interesting to note that this program is trying to help you to write code. Now, there's some weird looking stuff here, but if I squint and I look at it carefully, I can see that it actually says a semicolon. This little symbol right here next to the L on your keyboard is expected. And if I type that, that red squiggly line goes away. It was trying to help us by saying you forgot this thing. First the red squiggly says, look here. And then the tip there tells me what to do. What is this? What is this? Well, it's a line of code, y'all. You wrote code. Get over it. I'm going to save. I'm going to go back into Unity and let it think about what we just wrote. I can see it in the preview here when I highlight my script. Let's look at our coin for a second. What is this? On our script that we put as a component on our coin, there is now something that looks like this. It says position, this says move direction. It says X, Y, and Z. How did it know? Well, because we said vector 3, that's why. Literally, if we said vector 2, there'd be just X and Y. Cool. What did we want to do? Well, I wanted to do this, right? I wanted it to move over like 1. I'll hit Control Z. We wanted to do this, 1, right? So the move direction was really the only change we made here was this 1. It's a vector change of position where this is just 1. I'm going to set that right now. I don't expect it to do anything yet, but this is what I want it to remember to do. This is now part of the rule I want it to follow. Move the coin as this vector direction dictates. See, implied in that rule was actually a little bit of detail that we just figured out. I'm going to put a 1 right there. I'm going to save my scene. Why? Because now this is a coin that is set to move that much. We don't have the movement yet, but let's do that. This allowed us to store whatever change we wanted to do in X, Y, and Z. So it could remember it. That's great. But now we need to do it. And I'm not joking when I tell you code is about remembering things and doing things. Well, here's the remembering. We're going to remember what is the change in position. That move direction is this. That's what our script is going to need. The other part it needs to do is do. Let's write another line of code. And I'm not joking. this is something you can do. I'm going to put my cursor right in between these two curly brackets. It says start, it says start is called, and blah, blah, blah. Put your cursor right here, in between those two things. Because this line of code that we write will be done when we hit play. That's what start means. Isn't the rule to move the coin on start? Okay, that's what this is. Now I put 2 slashes and wrote that out. Is that okay? Yes, it's totally fine. I am going to write a line of code now that tells this game object, the coin. It's the game object with the square on it. We put the art of the coin on it. I'm going to tell the game object to move, and I'm just going to type game object. Yes, it already knows what I'm doing. Game object, yes, this. Very first one is lowercase g object, and forget about all the other ones. That is what we want. In fact, I'm just going to hit enter and let it finish typing that for me. That's how helpful it is. And there's this grayed out stuff after. What is this? Do I want this? Well, no. But you can type a dot, a period. Are we done with a sentence? No, we're actually doing something else, but just follow me for a minute. Because what I want to do is access that transform component we saw here. Let me go back to Unity and remind you, if we're here on the coin, because our script is here, what we're trying to say is go to the game object at the top and then find the transform component. We're going to then be able to access the position. That's where we want to go, because you remember we did this, right? So that's what we want our script to do. We're doing the same thing here in code. I'm going to hit a dot in order to access the transform. I could just start typing transform and it finds it for me? Huh? That's helpful. Yes, it is. In fact, look, it says transform and then grayed out it says transform dot position. Is that how you get to the position? Well, yeah, actually. Now, could we just let this suggestion from Visual Studio complete this entirely? We could. It's not correct. It's not exactly what we wanted, but we could. It's suggesting what it thinks we're trying to do, which is kind of funny. It's not very smart. But it's based on patterns, the way programmers write, and so it's right sometimes. Well, it is also a valid line of code, in fact. What does this say? It says, hey, game object, move the position to where this stored vector3 is telling you. Well, let's see what that looks like. Because another part of writing code is testing. It's science, computer science. This coin is at 0, 1.5, -8. And this says 1, 0, 0. If we actually make this equal 1, 0, 0, then it's over there. So actually that's not what we want, is it? I'm going to Control Z all that. We want to take this and add that. Can we do that? Well, let's see. I mean, first of all, let's just try it out because we're going to test it, right? We haven't done our test. If I hit play, it just moved. It moved on its own. It moved exactly that way we just showed. It is, in fact, at 1, 0, 0, just like what we have here in our move direction. If I hit stop, guess what? It's going to go back to where it was saved. 0, 1.5, -8. Wow. Why? Well, Unity is saying you configured your scene a certain way, and I've, saved it there. And it says, well, we want to maintain that. Even if you hit play, when you hit stop, it'll go back to what it was. It's made to do that. Think about it. You kind of want it to do that. But I really want to just add. I want to add all these numbers together, and that's the resulting position. Can we do that? Because if I did, then it would be 1, 1.5, negative 8, which would look exactly like what we want, right? Let's see. Can I just add like that? Could I do that? There's a thing I can do to make this stop highlighting when it's wrong and graying out when it's correct. What it's technically doing, I found out, is this is not called. Actually, I should probably. This is a function that's not called within itself, and it's goofy. I'm not going to explain. It's silly. It shouldn't be. But here's what I did. I highlighted this. This is the position of where it is right now. And I'm saying, you know what? Let's add that position where it is now to the position, the change that we want. Make the change. Add them together, because we thought that might work. Well, first of all, let's see if that works. There's another way to write that, by the way. Remember I told you there's more than one way to do things? If I hit play, let's see what happens. Could be totally weird. It is not totally weird. This 100 was now added, and it is now 1.58. When we hit play, the coin moves, and when I hit stop, it goes back. Do you see that we have implemented a rule and moved the coin? Wild. Now, it's not moving over time, but wait a minute. We can move game objects. This is a very common thing to do. It's also moving on start, which is a little silly. You might not need that in your game. But imagine we put this somewhere else. The rule was changed, so it did different things in different ways. Yeah. What is this line of code that we wrote? Well, this line of code says, remember what kind of change you actually want. This line of code says, when we hit play, set this position of this game object. And set it because we're just saying equals. Make it equal to something. And then we focus on the something, and it is that change that we want plus its position. This would be the same as if I said take the position and add the change. Be the same thing, right? There's more than one way to write it. In fact, if I remember correctly, we could say a fancy operator here instead of equals and say plus equals change. We don't even need this. I mean, should I test that theory? I think I could do this. Plus equals basically says exactly what we just showed you. Take this and add that. Make it equal to the result. That's what plus equals is all about. Let's see if that works. Remember I told you there's more than one way to do things? I'm going to hit play and see what it does. Hey, it moved. Exactly the same way as we like. Cool. So it did work. The same way. There's more than one way to do things. Whoa. Crazy town. So what is this? Well, bro, it's code you wrote yourself. I mean, you followed me, but you made the script. You typed the stuff. And you tested it out so that it works. It follows a rule that we made up. And now this coin follows that rule when we hit play. Every single time. Exactly the way we defined. And how do we know it? Because we tested. We're just good like that. Following best practices, you see. So, we can make this thing move. Can we make it move over time? Yes. If there's two things that a game engine does, it's dealing with space. Game space is in 3 dimensions, as we've been talking about, even if you're doing a 2D game. These objects are all sitting in 3D space. And the other thing it deals with is game time. So I think it's a good place to put it down, but that would be a good next step. If we can change the position of things with code, right? It doesn't matter when or what the rule is, if you should do that or whatever, or where to move it or anything, we can. I want you to consider that in the same way that we changed this, we could also change these things, the scale, the rotation, etc., with our script. We defined a rule. We tried it in the engine, what it would mean, paying attention to what that was, found out that we needed to remember a thing and then do a thing, because that's all scripting is. And we wrote the code to remember it, and we wrote the code to do it. Done. Yeah, done. In that way, as the bots show off spells and whatnot, in that way, are the bots showing off a spell, or did they upgrade the archers? I'll have to look at that later. In that way, what we've been looking at is a simple step that anyone can do. It took about an hour. We had some friends stop by. We talked about what it meant to do this small step of making our artwork, our pixel art we made last time and brought it into the game engine. We learned some things along the way last time, but we just have pixel art in a game engine. This time we said, let's move that art, just like things move in this game, Small Towers Down Below. And this is a small step, but along the way we learned a couple more things, and we're setting it up so that we could move it over time, like move animation. These things that we learned are small steps, but the game you're seeing down below is made up of lots of small steps. I didn't do anything more than one step at a time. And if you can take a step like what we just did this hour, you can do stuff like this yourself. Yes. We even wrote code, yo. Give me a break. So if you're interested in watching an ape talk about game design, do game development, whether it's art or code or story, then stop by. And when you do Command Tie. Command Tie lets me know you are here, and I can say hello, like I've done to our friends who stop by. Next time on this design workshop, we could move over time. Yeah. Move animation. Yeah. Just like the characters move across the screen and the arrows fly. Yeah. Just like the visual effects of the damage done floats up. Yes. Just like the coins float up when they appear. Yes. That movement over time uses what we did today and then deals with game time. We can do that. If you're interested, please do follow. Make sure your notifications are on. When you show up, please use Command Tie. And until then, have fun. Do well. Be good. Stay safe. See ya.